Hi everyone, welcome back to 3.5 for some more examples on some of the things we will see in finding the zeros of polynomials. Again, I want to warn you that not all polynomials are easily able to find those zeros. In our section in math classes, they're going to be set up nicely so you can find those zeros. In the real world, all bets are off. So here's an example. I have x cubed minus 2x plus 4. Sorry, that is an x cubed. And we want to find all of the zeros if I know that 1 minus I is a 0. So in other words, we've been given a starting point. If this was an integer, I would do synthetic division, and that would bring this down to a quadratic, which I could then factor or go to the quadratic formula. The synthetic division does work with complex numbers, so we can use complex numbers in synthetic division. Before I do that, because I am going to show you that it does work, I also want to remind us that if 1 minus I is a 0, we automatically know another one, because our complex numbers appear in conjugate pairs. So if 1 minus I is a 0, then 1 plus I is also a 0. So I have 2 of my 3 zeros. Again, it's 3 zeros because this is a cubic. So cubic has 3 zeros. I have real coefficients, so that means they have to appear in conjugate pairs. Okay, I'm going to show you that complex numbers do work in synthetic division. We just have to be a little bit careful. I'm then also going to show you another way to get it down to that lower degree polynomial. So I'm kind of dividing those pieces out. So first of all, synthetic division. So there's my 1 minus I that was given to me, and I'm going to divide it into this polynomial. But I have to remember that I need all of my coefficients. So there's my x cubed, my x squared, my x, and my constant. When you're doing synthetic division with complex numbers, you will get very good at multiplying them, because we're going to bring this 1 down, and then I'm going to take 1 times this, which is 1 minus I. Adding it to 0 is 1 minus I. My next step is to multiply these two guys together. So I'm going to do that over here. And I'm going to FOIL. So 1 times 1 is 1. My outers, my inners, and my last, that gives me I, that's a positive I squared. Now I have to remember that I squared is negative 1. So my plus 1 and my negative 1 cancel each other out, and I'm left with just negative 2i. So that's going to go here. Now adding, I can't combine them at all because one's real and one's imaginary. And now I need to multiply these guys together. Since I was told it is a 0, I should get negative 4, because that's going to have to add with that 4 to give me 0. But we'll double check. So 1 times negative 2 is negative 2. This is going to give me a negative 2i, a plus 2i. Notice the 2 i's are canceling. This is going to give me a plus 2i squared. But I squared is negative 1, so this is actually a negative 2. Combined with that negative 2 does give me negative 4, and we get 0. So here's our quadratic. We have x squared plus this guy times x plus this. That is really ugly. Okay? But we're okay. Just trust me, we're okay. I've done these before. So we also know that 1 plus I is a 0. So I'm going to just jump right in here and divide this guy out. Okay, so here we go. So I bring down my 1, I multiply, so that's 1 plus I. Oh, that's so nice, because my i's are gone, I'm left with 2. And then I'm going to multiply 2 by this guy, so this becomes a 2 plus 2i, and notice that, yes, I do get the 0. So even though this was ugly when we were done, once you take that second conjugate 0, everything's going to work out nice, and you'll then be left with nice integer values again. And this one represents x plus 2. So from here, I now know that x equaling negative 2 is my third 0. So my first 0, my second 0, and my third 0. I now want to make sure and go through and show you yet another method for getting down to this x plus 1. So if synthetic division wasn't something you liked, it's okay. We can work around it. And we're going to remember that, first of all, 1 minus I is a 0, which automatically told me that 1 plus I is a 0, which means that x minus this 1 minus I is a factor, and this x minus the 1 plus I is a factor. Now what I'm going to do is actually multiply those together. Okay, you might be thinking, oh, that's really going to be ugly. It is not. It will work out nicely. So first of all, I'm going to write this as x minus 1 plus I. So I'm distributing that negative through. And that x minus 1 minus I. Okay? And I'm going to go slow. So the x times the x gives me x squared. The x times the 1 minus x. This gives me a minus xi. Moving into the next term. Minus x plus 1 plus I. Moving here. Plus ix minus I squared. Okay, some really nice things will happen. Your I pieces canceled. Here's that minus I with that plus I squared is negative 1. So this is actually plus 1, which will combine with that 1 there. So this becomes x squared minus 2x plus 2. And so when you multiply these two together, you will get a nice quadratic that if you were to go into the quadratic formula, you would get those zeros. So you can kind of double check yourself. And now what I'm going to do is divide this into what we started with. So we're going to take that x squared minus 2x plus 2, and we're going to divide it into x cubed minus 2x plus 4. So the x squared, to turn it into x cubed, we need an x. So that's going to give me x cubed minus 2x squared plus 2x. And it will divide it evenly because, after all, it is coming from zeros. So we should get remainders of nothing. So now we're going to subtract, which changes our signs. And I end up with 2x squared minus 4x plus 4. To turn x squared into 2x squared, we need a 2. That gives me 2x squared minus 4x plus 4, and we're going to subtract, which changes my sign, and we get 0. So here again, we'll see that x plus 2 show up, which gives me my final 0 of x equaling negative 2. Okay, one more little problem that I want to just kind of remind you. I'm not going to actually go all the way to the end with it because I'm sure you guys are fine. Is a lot of times they will say find the, and they'll tell you a certain degree. So I'm going to say the 4th degree polynomial. And then they're going to list some of your zeros, or all of them. And you might have seen some of these in 3.4. So with zeros, and this one I'm just going to say 2i and 3i. So those are my zeros. And I need a 4th degree polynomial. But I've only been given 2 of the zeros. But if I have 2 complex zeros, I automatically know two more. They're conjugates. So this one is like 0 plus 2i. So 0 minus 2i would be another 0. And 0 minus 3i would be our fourth 0. So if these are two zeros, these guys are the other zeros. And that would be my 4 zeros that I need. Now I'm going to put it in factored form. So x minus the 2i. And this one would be x plus the 2i. X minus the 3i. And x like minus a minus, which gives me plus 3i. All I have left to do is to multiply this all out to get a fourth degree polynomial. I would strongly suggest that we actually multiply these two together because some nice things are going to happen, and these two together because some nice things are going to happen, and then multiply those results. So I will show you those nice things, and then I'll stop there because you'll see stuff you can do. This is stuff you guys can do. So foiling, my x times my x is x squared. I'm going to see that this one is going to give me a positive 2xi and a negative 2xi. So I will leave those out because they'll cancel. And this is going to give me a minus 4i squared. Here I have x times x, which is x squared. Again, my inners and my outers are going to be opposite in sign, so they will cancel. And then this gives me a minus 9i squared. But I squared is negative 1. So this becomes x squared plus 4 and x squared plus 9. And now I could multiply those together to get that polynomial. So actually FOIL one more time to finish. But I'm going to stop here with this video and end section 3.5 here, and just remind you to be patient with yourself. Take your time, watch your signs, your positives and your negatives. They tend to cause lots of little errors. So just be careful with them, and good luck.